Hello and welcome to my project for human factor in AI. First one, task analysis. So the problem that we're going to use is that many households waste energy because they lack insights into when and how they should consume electricity or use electricity. This leads to higher bills and unnecessary carbon emissions. The problem that we're solving is helping optimize their home energy use by predicting peak consumption times and recommending actions to reduce energy waste. The key task over here is monitor home energy usage, predict when use will spike, and suggest ways to shift or reduce consumption, such as run the dishwasher after 9 p.m. Insights is manual tasks are too complex for users and they won't check energy charts daily. A simplified workflow would be automatic monitoring, proactive notifications to the user, and then suggest actionable recommendations from there. And then there is opportunity to gamify this by weekly energy saving reports, comparisons with similar households, and so forth. User experience or UX design. The interaction that we're looking to use over here is going to be a mobile application. The inputs to this mobile application to our data source is using smart data meters, application search centers, user preferences, as well as electricity providers contract or tier by pricing sheet. The output will be energy forecast, recommendations for the user, such as shift usage, smart thermostat adjustment, appliance scheduling, and so forth. And then weekly insights into carbon footprint reduction, estimated cost savings. AI specific considerations, feedback loops. Users confirm whether they have followed suggestions, so the feedback then takes into consideration and understands whether the model needs to be adjusted, as well as users sets preferences such as prioritizing comfort or savings. So this way the model can adapt depending on the user's input. Transparency, show the why. So for example, your HVAC is running longer because the outside temperature is increased by 5 degrees Celsius. And then also visual dashboards such as graphs, the user breakdown per appliance, and so forth. And then communicating uncertainty, using ranges as much as possible. So giving insights into ranges, such as your electricity bill will likely increase by $10–15 if you continue usage this way. So giving that level of ranges rather than an exact number, and then also using confidence scores for predictions, such as 90% confidence or something along those lines as prediction as high, low, or medium. Privacy considerations. Data collected. Household energy patterns can reveal when people are at home or away, so that's something we have to consider. Appliance usage, sensitive data can hint lifestyle habits, and optional demographics data if the user provides it for benchmarking. Privacy concerns over here is profiling household socioeconomic assumptions based on energy use. And then applicable laws where applicable privacy laws such as the GDPR or the CCPA in California, or the energy sector standards such as FERC or NERC. Then to safeguards against these concerns is anonymize data and aggregate data when generating community insights. Strong encryption for real-time data, and allow opt-in for data sharing. Local edge processing where applicable. So minimize cloud storage and store data locally and the household if possible. Ethical considerations. Potential risk in production. Potential bias sources. Training data skewed towards certain household types, such as apartments or single-family homes. Appliance diversity. Some homes may lack certain types of appliances, leading to less accurate predictions. And then socio-economic biases suggestions may assume that all users have access to more expensive energy-saving appliances. Mitigation strategies use diverse datasets covering multiple geographies, housing types, and climates. Provide tiered recommendations, low cost versus high cost solutions, and then regular audits for fairness across the demographics. Ethical AI goals is, in fairness, ensure that system doesn't favor wealthy households or tech-savvy users. Accountability, publish model assumptions and provide context and supports for issues. And then transparency is clearly explain how predictions are generated and highlighting limitations. And thank you for listening. Bye.